Hello. So pretty much I'm going to be doing the 60 hertz airfoil simulation here. And so I already did the geometry. I believe it is figure 1-4 in our report. And it has all the SolidWorks dimensions and the airfoil dimensions all there. So once this machine loads, pretty much what's going to happen is we're going to name all of our boundaries with the name selections tool. We're going to name the outlet and inlet and wall. Then we're going to move on to doing a mesh refinement onto the edge of the airfoil just so that we can save resources, but we'll get more into that in detail in a second. So right now I'm going to be selecting the outlet, naming that outlet, then select the inlet, name it inlet, and then go ahead and select all the components on the outskirts of the geometry, and we'll signify that as wall. So the reason why we're doing this is this will tell ANSYS Fluent, our solver. Oh, I accidentally selected the inlet there. It'll say, hey, this is an inlet, so I don't need to go and find the actual edge of it inside of Fluent and name it velocity inlet. It'll automatically do it for us just for quality of life. So I'm just zooming into here, just going to name our airfoil as a name selection. This will make it easier for when we do the mesh refinement around the airfoil. So normally, one way we could just do this mesh is brute force it completely by just lowering the element size to like 0.0000001 meters. But the problem is your computer might not like it. It might not even load. It'll take a couple hours. You can really go overkill in the mesh. But that's not really practical, especially in like a professional environment. So what we'll do instead is use something like edge sizing, where we're going to grab an object. Usually in 3D, you could like make a cube or something or some type of geometry, and then select that area to refine that mesh and make that element size smaller than the outside geometry. So here you can see I lower it to 0.0004 meters, and once it's just done meshing, I'll show the whole mesh completely and how it sort of refines around the edge so we get more of a clear understanding of what's happening on the surface of this guy and around it. So once this finishes meshing, all right, just going to click the mesh icon in the workflow here. It's going to be black. Once we zoom in, you'll see all the nodes. And as you can see, it's more focused around that edge. And I hit update. It's good. It'll update to the workflow inside a workbench. We're all good. And so now we'll go to the solver. We're going to change the local processes from 1 to 8. You'll see this UI in a second. Um, so once this occurs, this will help speed up the simulation. It'll just use more of your local machines just in your computer. So here we go, 1 to 8. And of course, double precision for more accuracy, less truncation error and stuff like that. All right, so once the solver loads, you'll see vectors. You'll see red and blue vectors. This is already appearing because we use name selections to signify what's an inlet and outlet. So once this loads, you'll be able to see it. Here we go. So the blue is our inlet, the red is the outlet. Blue is it's a velocity inlet. You'll see this in a couple seconds. And actually, before we're going to use something called a journal. What a journal is I pretty much preset all the graphs from before, which is shown in a previous video by Tracer LabMate. Um, you'll see here, so 0. I'm going to read the journal. There's a typo in this journal. It says 30 hertz. The input's actually 60 hertz, so just keep note of that. To some misinput. I fixed it in a second. So you'll see before it's at 0 for in, and you can see how I loaded all the graphs and stuff, and it's ready. So once after it already initialized it too, so it's just ready for the calculation right off the bat. It's just nice for just repetitive tasks just like this, to where instead of just creating all the graphs, it's already done. I just plug in the journal, makes life easier. So once this finishes loading, you'll see the velocity inlet here. Computer froze. Yep, and here's all the objects going through all these creations here just from the journal. All right. So yeah, now we're going to run our calculations. We're going to set the iterations to roughly 1,000. It obviously will converge before then, but you'll see the iterations on the bottom. This, we're going to skip through this because this will take a bit. So see you right after this cut. Okay, so now that this is done, our calculation is complete. Now we're going to be able to see pretty much all of these plots for drag and like coefficient and everything. So here's our drag force plot. You can see it's negative, but that's because our it's a direction of our like wind tunnel. It's in the negative x direction, so our drag force will be in the negative x direction. It'll be in that direction. So easy way to fix it is, I mean, you can just take the magnitude of it, just be 0.3168. But just keep that in mind. It's just the direction of it. Doesn't signify anything else other than that. And from here, we'll see all these contours. We got our velocity magnitude contour. You can see this beautiful contour. We got our static pressure. Same thing. This is all in gauge. This is dynamic pressure. And then, yep, here's our velocity magnitude with our vectors. This would be sort of similar to the contours, but we'll just have little arrows instead, as you'll see once we zoom in. Yeah, look at those tiny arrows. All right, so now we finished looking at that. So we're going to load the streamlines and our post CFD, our results tab right after the solver once this loads again. And so we'll just see the streamlines from it. It'll look very pretty and everything. So there it is, the results right under solution. You'll just double click it, just get into it. And so from here, like I said before, we're just going to view the streamlines from here. Be nice, quick, and easy. But first, we got to reorient our view into the 2D plane. So we'll start messing with that axis. All right. And then from here, you see the little button. You just enter the streamlines. We'll just add the number of points, which will be 200. And we'll just compute it from the inlets and just hit apply. And then behold, in a couple of seconds after it loads, boom, streamlines. And it'll just show your thing. And there it is, all zoomed in. And that's pretty much everything. So hopefully this helps. Thank you.